Just 5 more minutes, sir. Good afternoon, all the participants. So it's my honor to introduce our speaker, Dr. Saroj Kumar Viswa, sir. So let me first introduce him through his biodata. So Mr. Saroj Kumar Viswas received his BTech degree in Computer Science and Engineering from Jalpaiguri Government Engineering College. Later, he did his MTech in Computer Science and Engineering from NITTR, Kolkata, and PhD from NIT Silchar. So, Dr. Biswas has been working as an assistant professor in Computer Science and Engineering Department at NIT Silchar since 2010. So, his research interest includes machine learning, artificial intelligence, pattern recognition, data mining, and image processing. To his credit, under his guidance, more than 11 students have completed their MTech, and more than 7 PhD scholars are doing their PhD, and out of them, 4 students have completed their PhD. So he has completed one deity sponsored R&D project, and currently he is working on NPIU World Bank sponsored R&D project. To his credit, he has published more than 40 international journals, including 23 unpaid SCI index journals in various reputed publication houses like Elsevier, IET, Springer, World Scientific, etc. So, hearty welcome to Dr. Saroj Kumar Biswas, and we would like to hear more from you. Sir, if necessary, please extend your timings whenever you are not able to complete. So, it is not hard and fast that you will stick to only 1.5 hours. You can take up to 2 hours also. So, hope all our students and participants will learn a lot in this 7 days workshop from you. Thank you so much, sir. We welcome you to start the session. Thank you so much. Can you hear me, sir?
Yeah, I can hear you. My slide is now visible to everybody.
Yes, sir. You can make it full screen, sir. Full screen. Yes, sir.
If my slides are not moving, then you can tell me. Sometimes it doesn't move actually.
Okay, sir. I will intimate you, sir.
Full screen visible?
Yes, sir.
So good afternoon, everybody. And in this presentation, in this workshop, we're going to talk about machine learning, and especially when we make a machine learning model, what are the phases are there? We're going to talk about all the phases one by one. And to process the data, number of techniques are required. Number of methods are there. So in this workshop, we're going to see mathematically those methods, mathematically those techniques, and also we're going to implement in a Python environment. That's the objective of the workshop. So initially you have to start with the definition with certain facts about those things, and gradually we come to different kind of techniques and their implementation and mathematical formulation of those techniques. So just I have given the title of this workshop as nuts and bolts of machine learning model theory and practical using Python. And nuts and bolts refers the different components of machine learning model. Already talked about when I make a machine learning model, different components are there. So before that, here just I started first slide of the works of that's the definition. My slide is moving or not? Yeah. So the first slide is talking about what is machine learning. This term is now well known and everybody knows about it, machine learning. But what is that actually? That's the objective of the first slide. So machine learning here, I have a line about a machine learning. It's trying to read out the line, then I'll explain. Machine learning is programming computers to optimize their performance criteria using example data or past data. So it's talking about machine learning as a method which optimize the performance criteria of a model using past data. So now the performance criteria can be accuracy, it can be error rate, it can be different kind of things for different kind of users. But I'll talk about how this performance criteria can be optimized for a particular model in case of machine learning. If we see carefully machine learning algorithms, the algorithm depends on certain model parameters. Now, if model parameters are optimized, only then we can get optimal performance criteria. But how can we optimize the model parameters? We can optimize the model parameters using past data or the historical data. Now you may have a questions, what are the model parameters? For an example, if we talk about support vector machine, in case of support vector machine, our objective is to find the weights of different attributes so that we can find the optimal result. Similarly, in case of neural network, our objective is to find the weights. So weights are the model parameters here. Using past historical information, our objective is to tune those parameters. If we can tune those parameters, then automatically the performance criteria of the machine learning algorithm will improve. That's the objective actually. And there are different kind of definition of the machine learning. There is no unified definition, but still there is one most popular definition which is given by Tom Mitchell. That one just I'm reading it out here. A computer program is said to learn from experience E, historical information E, with respect to some class of task. This task can be classification task, regression task, or any kind of task it can be. And performance measure P is a performance measure. If each performance at task in T as measured by P improves with experience E, that you find that logic is called machine learning. So it's talking about somehow we have to improve the performance criteria with experience. That is the main objective of say, Tom Mitchell's definition of machine learning. So let's define what is actually machine learning. What's the objective? Objective is to optimize the model parameters. If you can optimize the model parameters, then automatically the performance criteria of the model will improve. And those things are based on historical information or past data. Now, next question, why machine learning? Because we're having number of conventional methods. Can we not use those conventional methods to solve the problem? Yeah, we can solve the problem. The thing is that if we're having certain defined tasks, and for that, if we're having a reliable algorithm, then we don't need to use machine learning. For example, if we want to sort the numbers, we don't need to use a machine learning algorithm because there are a number of sorting algorithms. But unfortunately, we're having certain situation, certain tasks where we don't have any particular defined algorithm. If we don't have any particular defined algorithm to solve certain tasks, in that situation, we need to use machine learning algorithm. Now, the case if no algorithm is there, can we not apply a statistical method? Can we not apply some basic mathematics here to find to solve the problem? Yes, we can do. But whenever we solve this problem using mathematics and say statistics, using the conventional programming, that it takes time. And in machine learning, the algorithms are designed in such a way, once you just design the algorithm and if the inputs are given there, then automatically it can learn from the historical informations and it can solve the problem. So if you want to have a better and quicker decision to some unsolved tasks where we don't have any say, algorithms. In such a situation, we need to use a machine learning algorithm. For an example here that I have written online, for example, to tell spam emails from the legitimate emails, because in that case, we don't have any particular algorithm. Initially, we can have number of emails. Out of number of emails, some of them can be spam and some of them can be legitimate emails. Whenever we use a machine learning algorithm here, the machine learning algorithm tries to find out certain kind of patterns or the hidden patterns from those emails. For example, if you have a spam emails, from the spam emails, it finds a particular pattern. So whenever that particular pattern is encountered for a particular mail, then automatically the machine learning algorithm encounter or it will predict that that is a spam email. And in similar way, if you have some legitimate emails, it can have a certain kind of pattern. If those patterns are encountered in the next iteration, then the machine learning algorithm can say that's a legitimate emails. In that way, actually, machine learning algorithm works. The main objective of the machine learning algorithm is to find and extend the hidden patterns which are available in the past data or the historical data. That's the objective. And here, so what are the applications of the machine learning? There are a number of applications of the machine learning. We cannot exhaust the list, but those applications can be categorized into several dimensions. For example, here, these applications are categorized into these categories. These are the tasks. By these tasks, we can solve number of problems in application domain. So here, the application, the first one is learning association, then classification. With this kind of tasks it can do. So whenever we can do this kind of task, then we can solve number of problems in the application domain using these tasks. And by clustering here, the reinforcement learning we have here. So learning association, what is that actually? This is association rule mining. In this case, actually, it analyzes the basket. It analyzes the two variables, two independent variables. It finds the conditional probability. So sorry, two dependent variables. It tries to find certain kind of conditional probability. I'm not going to explain in detail, but showing you one application here. For example, to find certain kind of relationship between two things in the chips and the beer, now say the probability is this, and this is actually conditional probability. That thing actually is done by learning association. Now say this probability is 0.7. What is that actually? It says that what is the probability of chips if beer is given? It says that if some customers buys a beer, then there is a probability that is 0.7 that the customer also buys the chips. So that is found using 0.7, and it is the conditional probability. So if the customer buys this one, the customer also buys this one. So now this result is 0.7. Now the question, if you get 0.7, then what is the benefit of that? Yes, we have the benefit. Whenever we push order, if you talk about the supermarket or a big bazaar kind of thing, whenever they maintain a stock say maintenance kind of thing, or they are putting order for the items. So if we get this kind of probability, then whenever the supermarket puts an order of 100 bottle of beers, the market also gives the order of 70 bottles of chips, so that in future there won't be any mismatch and shortage between beer bottles and the chips. That thing actually is done in the supermarket by a big data analysis. This kind of thing is done. So this kind of task belongs to learning association. This is one of the example. And here we have another example, the classification. Using classification, we can sort out number of problems. Thousands and thousands of problems are being sorted out using the classification. So here, just I have taken two here, the cancerous tumors. This is an application of image processing. And again, to try to understand, image processing is an application of machine learning. Machine learning is the matter here. So in the cancerous tumor, how we can do? So we can take a picture of tumor, whether the tumor is a benign tumor or malignant tumor. It can be found out using several dimensions or several parameters of the features of the tumor size, tumor color. Using those things, the machine learning algorithms, image processing algorithms can classify it, whether it is a cancerous tumor or non-cancerous tumor, whether it is a malignant or the benign tumor. So we can classify in that way actually in case of image processing. Similarly here, good payer or bad payer. Nowadays, whenever somebody applies for a loan, now it's a big banks, and meanwhile it is not done whether the loan could be granted or not. So generally the banks are having now the automatic software. Whenever the inputs about a person is given, then automatically the software generates whether the person is good payer or bad payer, based on the inputs. For an example, age, occupations, per month income, those things are given, and based on that, the algorithm finds a score. Finds a score. Based on the score, it decides whether the payer is good or bad. If the payer is good, then the loan will be granted. If the payer is not good, then the loan won't be granted. So these are the two applications here for the classification. But you try to
మస్తు
understand.
మాట్లాడుతున్నావు సార్, ఇంగ్లీష్ జబర్దస్త్ మాట్లాడుతున్నావు, కానీ ఏం అర్థమైతలేదు సార్.
Well, I could not understand what you're saying about it.
Participants, you can unmute and you can talk with our speaker.
Okay, fine. So here, this is the application of the classification. So there can be number of applications of the classification. Similarly, here the regression, right? In case of classification, the objective is either the output is 0 or 1 or some discrete values. But you try to understand, if we have a problem here, we are going to find some continuous values, not the discrete values. In that case, this kind of problem is called regression problem. So in regression, we are having a number of machine learning techniques by which you can regress the values, or regression kind of things can be done. So one of the example here is the rainfall predictions. So rainfall can be predicted based on certain values, say temperature, maximum temperature, minimum temperature, humidity. Those things can be the input, and the output can be the rainfall prediction, so the rainfall amount. So rainfall amount is not say discrete value, it's a continuous value. So whenever the predicted or the dependent variable becomes a continuous value, then we can say that kind of problem is a regression problem. They are not classification problem. So in case of regression, we can find the rainfall prediction, price of a car, price of land, different kind of things or different kind of problems can be sorted out. And here we have a cluster. So clustering is unsupervised learning. We're going to talk about all those paradigms, right? So in this case, what generally they can do, they can find different state of customers by which it can improve customer relations. For example, say LIC is an organization, right? So now different customers are there. Based on the values of the customer, it can make different clusters. For an example, one of the cluster is a very dense cluster. Looking at the parameters of that cluster, that the age of the customers in between 30 to 40, and that is the dense cluster. Means most of the customer ranges in between 30 to 40. So whenever the LIC looking for the potential customer, their objective would be the person whose age is in between 30 to 40, because they are the potential customer. So this is the use of clustering. Then we have a reinforcement learning. Using the reinforcement learning, this kind of tasks can be done. So robot navigation, autonomous driving, adaptive decision making. I'm not going to talk too much here, but you try to understand whenever we have a decision, we have a task where some kind of adaptive decision making or adaptive situation is there. This adaptive decision making or adaptive situation is to be implemented using a reinforcement learning. So now here we have this kind of classification things. I'm not going to talk about those things, but here we have seen this kind of tasks up here, right? Using these tasks, we can sort out different kind of application. We can use in different kind of applications, and different kind of problems can be sorted out. So here we have that already talk about the machine learning. Based on the learning paradigm, the machine learning algorithms can be classified into 3 categories. And these categories are here. The first one is supervised learning, unsupervised learning, reinforcement learning. In supervised learning, already we have seen different tasks are here. So classification and regression, they belong to supervised learning. Clustering and association, rule mining, this belongs to unsupervised learning. Q learning belongs to reinforcement learning. These are the tasks which belong to different learning paradigms. And you try to understand here, I did not include semi-supervised learning because these are the categories based on learning paradigm. In case of semi-supervised, the learning paradigm is not different. That's why based on the learning paradigm, just the machine learning algorithms can be categorized into 3 categories, and these are supervised, unsupervised, and reinforcement learning. Now coming here, so which are the supervised learning and in what situation the supervised learning should be used? See here, right? One of the table, right? This is the data, the small data only, right? Just for the convenience to understand data. So here we have a data set. In this data set, how many data we are having, how many patterns we are having, how many samples we are having. These are called samples actually, right? 1, 2, 3, 4, 5, 6, 7. 7 samples are there. And in those samples, we are having some independent variables and also we're having dependent variables. Here in this case, BP, heartbeat, and weight, these are the independent parameters and class is the dependent parameters, right? So if we have a such kind of data where we have some dependent parameters, using the help of independent parameters, our objective is to find the dependent parameters. Then if this kind of learning is done by some algorithms, then we can say those are the
Hello,
supervised
sir.
learning.
Hello, sir. Can I just stop you for a minute?
Yeah.
Sir, my students are first year students.
Yeah.
So please talk very slowly because they don't know what is ML. They are very new to ML. So I request you to, they are unable to understand. So please tell them in detail what is machine learning and in detail very slowly. They are asking us. Okay.
I'm going slow here, right?
Yeah.
So
Thank you so much.
already we talk about the machine learning algorithms can be categorized into 3 categories. The first is supervised, unsupervised, and reinforcement learning. And in supervised learning, we are having 2 tasks. One is classification, another one is regression. And under unsupervised learning, we are having clustering and we are having association. And in reinforcement, we're having Q learning. Fine. And now, if we have this kind of data, right, this kind of data, so in this kind of data, the learning algorithm which can be used, that is called supervised learning. Why? Because in this case, in the learning, we have a supervisor and that is a class level here. If you see each sample, this is one sample, this is another sample, this is another sample, means one pattern. This is another pattern, pattern. These are the patterns. Now for each pattern, we are having one output. And this output is called dependent variable. And these independent variables are called inputs. So whenever we give the inputs, if input is 120, this is 70, this is 50, then we can say yes. For an example, say this is the case of somebody is suffering from diabetes or not. If BP is 120, this is an example you try to understand, right? For the demonstration purpose only. These are not actual values. So if BP is 120, heartbeat is 70, weight is 50, yes, the person is suffering from diabetes. See, similarly, again, if we have this input 125, 65, 60, then again we can say yes, right? So in that way, actually, if these, then we can say no. If these, then we can say no. In that way, we're having number of samples here, right? So if the training is done in such a case or in such a data, then we can say these are the supervised learning. Now you can have a question, which are the supervised learning algorithms? So here we have a number of supervised learning algorithms. The first one is naive-Bayes, then we have a decision tree. In the decision tree, we are having a number of variants, ID tree, C4.5, C5.0, and card. And then again, we have a support vector machine, artificial neural networks, k-nearest neighbor. These are the algorithms by which we can classify a task. And here also we have certain kind of regression algorithm. What is that? Already talked about regression. It also belongs to supervised learning. So if we have this kind of data, right? Here we have a roll number, here we have age, here we have height. And based on this input, if our objective is to find where of a student, there's 23 point something is there, and 14, this again, based on this one, if this is the output, 21 point something is there, to try to understand here, we have the output, but the outputs are the continuous. So whenever we have a continuous output, not discrete output, then we can say this kind of problem is a regression problem. This kind of problem is a regression problem. Now to solve regression problem, we are having number of regression algorithms here. So linear regression, polynomial regression, logistic regression. A number of regression algorithms are there. Later we'll check on and later we'll see. Before looking forward about different kind of say algorithms, just I have some facts I skipped here from here that I'm going to talk about. These are the some facts about machine learning. Whenever we talk about the machine learning, these are the facts and these are called tenets of machine learning. The first thing is it does a good and useful approximation. And I try to understand whenever we have certain event, a statistical event or any kind of event. In the event, there is certain kind of relationship. That relationship can be beyond of our understanding, beyond our intuition, but there is certain kind of relationship, right? And that relationship can be caught, it can be approximated using some machine learning. So machine learning doesn't guarantee to find you the actual and the perfect estimation or the perfect relationship. But again, it finds at least the approximate relationship in the event. If there are number of attributes, number of say events, number of say independent parameters, which kind of relationship is there, it can be found using some machine learning. This is a fact about machine learning. Another fact is it uses the theory of statistics in building mathematical model because the core task is making inference from a sample. Because in case of machine learning, we have a sample, and from the sample, we're going to do certain kind of inferences or certain kind of decision. So you try to understand if you are statistically sound, if you are mathematically sound, that you can understand machine learning very well. If the statistical part is missing, if there is some lack of say methods kind of thing, so you have to read on that. In mathematics also you have to read on that. Only then you can understand the mathematical part of machine learning algorithms, right? So application of machine learning method to large data set is called data mining. So whenever data mining is not other than say machine learning, whenever machine learning is applied to a big database, then we can say that is data mining. And machine learning is a part of artificial intelligence, right? So artificial intelligence and machine learning, they are not same. Machine learning is a subset of artificial intelligence because artificial intelligence includes more than machine learning. Machine learning helps us to find a solution to many problems in vision, speech recognition, and robotics. Machine learning can do some certain kind of predictive tasks, and it can also do certain kind of descriptive tasks. What is the predictive task or the prediction? Prediction is talking about we're having certain things, and we can predict whether the event would be or not. That is called a prediction. And description is what? Description is talking about if certain things happen, why the things happen, what is the reason. Those things also can be explained by the machine learning algorithms. We are having certain kind of machine learning algorithms. Those are called white box model, by which we can find out what is the reason, or what are the reason to particular problem. So these are the facts about machine learning. So we are standing here in the supervised learning, already talked about. After supervised learning, we are having unsupervised learning algorithms. What is actually unsupervised learning? So here we have a data set, again same thing, this is a sample x1, x2, x3, x4, x5. And this data set, data x1 is characterized by three attributes, and attributes are a1, a2, and a3. These are the input parameters, you can say. These are the input parameters, right? But in this case, we don't have any output parameters. We don't have any outcome. Just only we are having the input parameters. Similarly, in case of x2, we are having only the input parameters. x3, we are having input parameters. So in the whole data set, we're having only the input parameters, but we don't have any output. In such a situation, if we want to learn something, which kind of thing can we learn here? The things, what are the regularities? What are the hidden patterns? What can be generalized from the inputs? Those kind of things can be learned from this set. So whenever some kind of learning is done in such a data set, then we can say this kind of learning is unsupervised learning. So in unsupervised learning, we're having two tasks. One is clustering, and another one is association rule mining. In clustering, we're having number of algorithms, and these are the some basic algorithms. K-means clustering algorithm, K-meta-wide algorithm, Q algorithm, BITch, and association rule mining. We can find set of rules. Why set of rules by which we can explain the regularities among the data. And we are having a number of algorithms here. A priori algorithm, predictive a priori algorithm, TS algorithm, ECLAT, and then we have FP growth. These are the rule mining algorithms. And after that, we have a reinforcement learning. What is that actually? If the data set is like that, we have a input variables, input parameters 120, with 70, and here we have 50. But in output, we don't have any particular output. We don't have any class. But in the output, we have a kind of feedback here. So these feedbacks are, say, this feedback can be given as a reward or penalty. Penalty, penalty, reward, reward, reward kind of thing. Now the question, what are the reward and what are the penalty? So here again, during the learning, If the algorithm is going in the right direction, then some kind of reward will be given as feedback of the learn to the algorithm, so that algorithm can understand I'm in the right direction. So the learning paradigm, what I'm doing, it's okay. If the algorithm is not doing or not going in the right direction, then certain kind of penalty is associated with that. So penalty is some kind of punishment, some kind of negative value is assigned to the algorithm. So whenever certain kind of negative value is assigned to the algorithm, then the algorithm can understand I am not in the right direction, so I need to change here. Now you have a question, how much reward can be given and how much penalty can be given. It totally depends on the problem. And you have to make some equation for that, how the reward can be calculated. If the error is this, then this, if the error is this, then this kind of penalty can be given. If the algorithm is in right track, then this kind of error can be given. For that, you need to have certain kind of equation. And here, in case of reinforcement learning, we are having number of popular reinforcement learning algorithms. This is random Boltzmann machine. This is deep Boolean network. Then we have deep Q network. This is the most recent algorithm by which many people are doing works. Those who are doing work in reinforcement learning already talked about. If you have a situation where the decision is adaptive, in such a situation, reinforcement learning should be used. So deep Q network, you can see if you work in reinforcement learning algorithm. So we talked about the different kind of algorithm, different kind of learning paradigms, and the scenario, the situation where those things should be used. Now we're coming here. What is that? This is, it is talking about, see carefully, as a machine learning model. So already you know what is machine learning. By machine learning, a different kind of learning paradigms, means techniques we know. So now if we jump to make some kind of machine learning model, then how we can machine learning model? This is the model what generally our team actually follow to make any machine learning model, and that is the pipeline, or you can say that is the sequence here. So initially, in the machine learning model, we must have a data set. We must have data set. So when the data set is available, then we have to do data preparation. And I try to understand more than 50% time is given for the data preparation. Because if the data preparation, please mute and read. Somebody is talking.
అరే మేడం పేజ్ చూడరా ఎట్లా పెట్టిందా ఒక్కసారి అదిగో
Somebody is talking, madam. You can tell him or her.
Yeah, hello students. You can directly talk to sir if you have any doubts. Please ask your doubts.
You see that we have cemented work. Hello, I just listen one thing, one statement I'm telling you. You may have a number of doubts, number of things, because as we have started some machine learning subject. So some concepts are given here, things are not clear, may not be clear, but you try to understand. I'll explain each and every one with example. Just keep your patience. Everything will be clear with examples and with practical with the patience. Everything will be done, right? Everything. Just keep whichever questions you are having right now, just write down and just keep it with you. And
Sir, look into the messages also in the chat box if they are asking any doubts time to time.
okay, madam, I cannot track there. Or rather, if there is some question, you see the chat box and then you can tell me.
Okay, sir. Okay, no problem. Carry on.
So whenever we make a model, then this is the follow. Actually, the data set, when the data set is available, then we have to make the data preparation, and that's very crucial. More than 50% time is given for the data preparation here. If the data preparation is good, then the training of the algorithm is good, then the generalization capability of the trained model, what are we going to make, will be very good. That's why data preparation is very crucial in machine learning algorithm. After data preparations, then we have to come here, that is called modeling and evaluation. In modeling and evaluations, what do we need to do? We need to do model selection. Arbitrarily, we cannot jump to any one of the machine learning algorithm. First of all, we have to understand which kind of task we're going to do. And based on that model, we have to select the model. That is called model selection. So in detail, we're coming to model selection actually later on. And then after selecting the model, then we have to train the model. After training the model, then we have to evaluate the model. That's how the model is performing after training. Those things we have to do. So before doing this modeling and evaluation, we have to talk about the data preparation. In data preparations, these are the tasks what we do. These are the tasks, see carefully, these are the tasks what we do. The first one is the removal of corrupted data. Then handling missing values, data visualization and data exploration, then outlier detection, then treatment of class imbalance problem, then feature analysis, and finally data normalization. Just I have given a sequence here, but you try to understand based on your application and the application domain, you can change the sequence. But overall, on an average, whenever you do the data preparation, that you have to do this kind of tasks, this kind of phases, or this kind of things you have to do. So I'm going to do in detail all those things in one by one. So the first one, so we have the database, right? Initially we have a database, that's what coming here, the database. So first of all, whenever you're going to make a machine learning model, you have to identify the problem. That's called problem identification. Means which kind of problem you're going to solve, that one you have to identify. After problem identification, then you have to identify the data. Means to solve that task, which kind of data would be available, which kind of data would be required. You have to identify those data. So after identifying, you have to acquire the data. You have to obtain the data. So the data acquisition can be in different ways. Those things you have to do. And then the database is ready for doing all these tasks.
Sir, is it possible to increase the volume still?
Yeah. Done. So now here, so now we have a data preparation. In the data preparation, the first one is we have a removal of corrupted data. Removal of corrupted data. So the first of what is corrupted data we need to know. So the corrupted data can be defined as the four things are there: not in range, not in format, outliers, missing values. But you try to understand as the outlier is a big topic. That's why we kept here outlier as a separate step, and missing value also is kept as a separate phase in the model. And here we just going to talk about the not in range and not in format. So if we have the corrupted data, then this corrupted data has to be removed. Only then the training can be better. So if we remove those things, then what would be the benefit? The benefit is it improves the quality of the training and the reliability of the learning model, or reliability of the solution if we do removal of corrupted data. So whenever we have certain kind of erroneous data, so for an example, we have this table. In this table, we have a samples, and each sample is defined by 5 parameters: A, B, C, D, and E. And we're looking at the values which are associated with E parameter. These are corrupted data. These are the erroneous values. So then these values can be discarded, and after that, the remaining, the rest of the processing can be done using A, B, C, and D. Here we have an example. See carefully. Here we have an input where we have some samples here. So age is given, weight, height, pressure, and then we have heartbeat. So in the first sample, you see we have a 25. So age 25 is a possible. So weight 54 is a possible. Height 5.6 is possible. Pressure 110 is a possible. And here we have a heartbeat that is 300. That is not possible, right? There's a corrupted data. Somehow it is distorted data. So similarly, in the second example, second sample, looking that all values are possible, but here if you see the heartbeat, in the heartbeat the value is 400. So these values are not possible, right? The heartbeat cannot be 300, heartbeat cannot be 400. So somehow these values are distorted. So as these values are distorted, so that now we can say these are the distorted values or erroneous data. So whenever we have this kind of erroneous data, distorted values, those things should be removed. Those things are the corrupted data. So after removing this part, we have now this data set, right? So we have age, weight, height, and pressure only. Fine. So one more example here, just here. So we want to make one system, one say mobile application by which using say symptomatic say attributes we can predict whether somebody is suffering or the fever is a dengue fever or not. So we had this kind of initially we had this kind of data with us. So this kind of data, and looking here, there's a dengue platelet. The value is 140, 80, 120. So the platelet value is 120, 80, 140. Those things cannot be. So these are the corrupted data. We omitted this data. After omitting this data, we have taken this data, and out of this data again we have removed some of the unwanted data later on. But this is one of the corrupted data we can see. So here already talked about the removal of the corrupted data, right? If the data is like that, then we can say that is the corrupted data. After that, we're having here handling missing values. Handling missing values. So what is handling? What is missing values actually? So we have this kind of data set. In this data set, we have this value, the value is not there. Here also, value is not there, value is not there, value is not there. So these kind of values are called missing values. So you try to understand if you have a missing values, if you train a model, then the generalization capability of the model won't be better. So whenever we have certain kind of missing values, then we need to remove it. So whenever we remove the missing values, then it improves the quality of the training. As it improves the quality of the training, that's why the generalization capability of the model will also be improved. So whenever we have a missing value, somehow those values has to be removed now. So how we can handle the missing values? So to handle the missing values, we're having two ways, and these ways are deletion and data imputation. So how we can do those things? Now we're coming here for the deletion. So if we talk about the deletion, then this deletion can be done in three ways, and these are deleting rows, deleting columns, and pairwise deletion. So coming one by one, what is deleting rows? Means what? So see here carefully this data set, this data, chunk of data. So looking here, this value is missed from here. So this value is not here. So what we can do now as a beta, the whole sample, the whole row, one row represents a sample. So whole sample can be deleted from the data set. So whenever we delete this sample from the data set, then the actual data set becomes like that, right? This is the refined data set. So now you see carefully this refined data set, and there is no missing values. So whenever there is no missing values, now if one machine learning algorithm is trained here, then the generalization capability of the algorithm will be better, right? So whenever we have this kind of values, so we can delete the values using, say, deleting rows. So now we have this kind of situation now. Looking here, we have a missed value. Here we have a missed value. Also here we have a missed value. So looking that in three samples, we are having missing values, right? So if now we delete the rows, then how many rows we need to delete? 1, 2, and 3. 3 rows we need to delete. So again, you try to understand if you delete 3 rows, and if the size of the data set is less, but still you are deleting some of the samples from there, then now the size of the data set becomes very much reduced. So if the size of the data set is reduced, then the generalization capability of the data set will be lower. So in such a case, if we are having number of missing values for a particular columns, then it's better to delete the whole column, not to delete the rows. In such a situation, we can delete the whole column. So if we delete the column, then we'll have this one column, one attribute is deleted, and now we're having only the two attributes, BP and weight. Based on BP and weight, now we have to classify the task. This is deleting columns. After deleting columns, here we have the pairwise deletion. What does it do actually? It pairwise deletion. It deletes column-wise. So it deletes columns as well as it deletes the rows wherever it finds certain kind of missing values. So see here we have a number of missing values. So it deleted this one, right? Deleted this one. At the same time, it looks that here also there is a missing value. So 154, this sample is deleted from here. So after deleting this one and this one, now we have this refined data set. But you try to understand in pairwise deletion, the part is not permanently deleted. Right? For the purpose of the evaluation or the training, only the part are deleted temporarily. So we deleted this part, and we are having this refined data set. Using this data set, now the training can be done. So again, we can have a different thing here also. What? Yeah, this one is, we kept this one now. Heartbeat is not deleted. We kept BP, right? And where is to be deleted now? Say, for an example. So where is deleted, and one of the row, yeah, this row. No. Just we're keeping here heartbeat, this one, and one of the row is deleted. Yeah, this one is kept here. Which one? BP, and we're having heartbeat. So which heartbeat we're having? This 70, 59, 66, 75, and 67, and 120 for this one, 154 by default it comes actually, So it can be 115 only. In that way, you can keep. So now in that way, actually in the pairwise deletion, deleting rows and deleting column, and pairwise deletion we can do. So in that way, deletion can be done. If you're having the missing values by deletions, the missing value can be out or can be removed. So another way of handling missing value is the data imputation. Data imputation. See here the data imputation. What is that actually? Data imputation means creating data. Synthetically, we are going to create the data here. We're not going to delete the rows or the columns. It can be that the size of the data set is very small. So if the size of the data set is very small, and if we delete some of the rows and columns from there, then the generalization capability can be reduced. So in such a situation, what we can do? We can impute the data. So for example, here we have a missing values. Here we have a missing value. Initially, we didn't have value here, right? So we can impute the data. How we can impute the data? For the data imputation, we're having a number of techniques. These are the techniques: mean, median, can be mode, linear interpolations, linear regression, KNN, and different kind of machine learning can be used to impute the data. So now if we adopt here the mean to impute the data, then how we can impute the data? See carefully, that we can take all the values: 70, 65, 59, 66, 75, 76, 56, 70. We take all the values and we find the mean. And by mean, this value can be filled up. So in that way, you can impute the data if we adopt mean as data imputation technique. So we can impute the data here by mean. Similarly, here if we have a categorical values here, the categorical, then we cannot find the mean. So what we can use? We can use a mode here, or we can use a KNN. So the value of K is 4. So we need to see the K nearest neighbor, 4 K nearest neighbor. So here 1 and 2, 1 and 2. So out of 4, how many 3 yes and 1 no? That's why in KNN value is value equals to K equals to 4. In that case, the value can be generated or imputed based on majority of voting, or you can say mode of the values which are available. So here it can be Y. So in that way we can impute the data, right? So similarly, different kind of linear interpolation and linear regression algorithm can be used to impute the data if the values are continuous. Those parts can be done. So after say handling missing values, then we have a data visualization and data exploration. What is that actually? If we do data visualization exploration, what is the benefit? It helps to understand underlying behavior of the data, which helps to take right step in data preparation and modeling. Because in data preparation and modeling, we have to do number of tasks, number of things. You can see later. We'll see together, right? So what kind of decision, what kind of tasks we need to do? So if we know underlying behavior of the data only, then we can understand. So how we can understand the underlying behavior? For that, we're having two tasks. One is called data visualization, and another one is called data exploration. So then we can understand very well what is the behavior of the data. So initially come with data exploration. Here we have a data exploration. So how we can explore the data? For the data exploration, we are having number of statistical methods. Number of statistical method we have. So here, just we are going to see 3 statistical measures, and these are mean, median, and variance. By mean, what we can understand? We can understand the central tendency of the data. By median, also we can understand central tendency of the data. By variance, we can understand data spread. So here, one thing, if we can understand the central tendency using mean and also using median, then what is the use to use 2 measures, mean and median? There is a necessity. See here, but how mean and medians are used for data exploration. So see here, we can have a set of observation. This is the set of observations. So here we have the observation. The value of the first one 21, then of 89, then 34, 67, and 96. Now to find the mean will be 61.4. And if you find the median here, then it will be 67. Because whenever I find a median, the values has to be sorted in so we have to sort the values in ascending order. Then only can find the mean value, the median here. Fine. So now see here, there is no big difference between mean and median. So try to understand whenever there is no big deviation, a difference between mean and median, then we can say the observations are well distributed. Still, we cannot say exactly actually, but it appears that the observations are well distributed if mean and medians are same. So generally, it is expected that whenever the samples are data is uniformly distributed, then mean and median, there only big deviation between mean and median. See another observation here. We have another set of observation here. So these, we have this kind of observation. Now, if we find mean of those observations, then the mean value becomes 46.11. Now, if you find the median, then the median becomes 25. So now, if you see carefully, the difference between the mean and median, then a big difference between mean and median. So whenever, see here, the mean is 46.11 and the median is 25, so big difference is there. So whenever big difference is there, then we can assume that the observations are either concentrated to the lower values or the observations are concentrated to the higher values. See, there are made red mark, red color, all the values. So see these 21, 20, 23, 24. So most of the values, most of the observations, not most, so many observations concentrated to the lower value of the observations. So whenever we have a big deviation between mean and median, then we can conclude two things. Either the values are concentrated to the lower values and values are concentrated to the upper values. So values are not uniformly distributed, right? This is one of the case. And we have another case here. Again, we have a set observation here. So 21, 89, 34, 67, and 200 here we have. Now, if you find the mean of that, it becomes 82.2. And if you find a median, it becomes 67. Again, if you find the differences and the big differences between mean and median. So again, you try to understand if there is a big differences between mean and median, then there is a chance to have outliers in the observation. Because if we have only minimum number of outliers in the observation, then automatically there would be a big deviation between mean and median. So if you see carefully the values here, we have 21, 89, 34, 67, and see here 200. 200 is the outlier because this value is totally different than the other values. The behavior of these values is different than most of the or rest of the observations which we have here. So another conclusions here we have whenever there is a big deviation between mean and median, so there is a chance to have outliers, right? So now we have another case here. So we have A1 and A2, we have two samples, and these are the values and these are the values, right? And now, if we find from the two samples, the mean and median, both 46, 46, right? Both 46, mean and median, both 46, 46 from both of the samples. So it is then what we can say? We can say that they are well distributed, only that. But if we are not restricted, only well distributed, if we want to more about data distribution about these two samples, then what we need to do? We need to find this variance and standard deviation of the data. Then we can conclude something more because here we have a two state of observation, these and these, or you can say this attribute and this attribute. In both cases, mean and median both are same. But I want to know something more on that. Is there something more on more there or not? So if you want to that one, then you have to find the spread of the data. It means the variance and standard deviation. Now, if you find the variance of this A1, the variance becomes 2. And if you find the variance of this A2, this is A2, this is A2 actually, sorry, this is A2, that's 79.6. That is 79.6. This is A2, and that is 79.6 here we have. So from here, what we can conclude? We can conclude A1 values are concentrated around the mean, and A2 values are extremely spread out. So if we want to have the behavior of the data, and the behavior of data that we can understand from here. Now we can have a question, sir, if you know the behavior of the data, then what is the benefit? Sir, already we have seen that if we have a big deviation between mean and median, so there is a chance to have outliers. So if I have outliers, then outlier detection technique has to be used to the data set. Number one, if there are very much scattered, if the data spread is more, then we need to use certain kind of algorithm which can capture the distributed data. So those things we can understand whenever we explore the data. So here, using a statistical measure, we can understand the behavior of the data. Similarly, see here, by data visualization, we can understand the underlying behavior of the data. So here, we can have a visual view of the data behavior. So whatever we talked about earlier, So all those things can be visually observed. So in the data visualizations, one of the powerful tool, and that is called box plot. So whichever things we have discussed in the data exploration, all of the things can be seen by one shot if we make box plot. So so box plot is an effective mechanism to get a one-shot view and understand the nature of the data. So this is the structure of the box plot, right? So in the box plot, we're looking at some lines are here, some lines are here. What is that actually? In box plot, we are going to find the 5 statistical summary. And based on these 5 statistical summary, we can conclude number of things. So coming here, which are those actually? You see here carefully. This is the box plot of an attribute. Similarly, this is the box plot of another attribute. Similarly, this is the box plot of another attribute. This is the box plot of another attribute. So if we maximize one of them, say this one is taken here individually, and this is the picture here. This is the picture. So see here what we have: 1, 2, 3, 4, and 5. This is what actually this statistical summary is called minimum value. And this one is called first quartile. This is called the second quartile. Second quartile means the median value. And this is third quartile, and this is the maximum. So whenever we make a box plot, then we have these 5 statistical measures: the minimum, maximum, and this is the span of the box. This is the span of the box. The box spans from Q1 to Q3. So if we have a minimum and maximum, what is the benefit here? Try to understand. If we have certain values beyond this minimum and beyond this maximum, then it is assumed that these values are not normal. These values are exceptional. So whenever it becomes exceptional value, then we can treat those values are outliers. Now we have a question: so how we can find this minimum, first quartile, second quartile, third quartile, and maximum? That's the question. So see here, this box spans from Q1 to Q3. Already talked about this one is called Q1. This is called Q3, and this is actually median, Q2. So initially, to find the minimum, we have to find the lower range. Try to understand. To find the maximum, similarly, we have to find the upper range. So how we can find the lower range actually? So again, you have a question: how we can find Q1, Q2, and Q3? We have an example later. We'll see with the example how we can find the values of Q1, Q2, and Q3. But now say Q1, Q2, and Q3 are known. So how we can fix the minimum and maximum? That one we're going to see here with this example. Now to find the minimum value, we have to find the lower range. And lower range extends up to Q1 to Q1 minus, this is minus, Q1 minus 1.5 times of IQR. What is IQR? IQR is interquartile range. Now the question: what is interquartile range? This interquartile range is nothing, that is the span between Q1 to Q3. And the value can be found using which one? Q3 minus Q1. That is called IQR. So whenever we find the lower range can be found using Q1 minus 1.5 times of IQR. And IQR can be found using Q3 minus Q1. Now say we have a data sample that is X. And we have, for X, we have these values. The Q1 is given here. Later we'll see how we can find Q1. So Q1 is 73, Q2 is 76, and here Q3 is 79. So if we are having these values, what is the value of IQR? Already talked about IQR is 1. This is Q3 minus Q1. So now it becomes 6. You try to understand again, I'm telling, repeating, this is Q1 value, this is Q2, and this is Q3. So now we got here IQR, that is Q3 minus Q1. So value of Q3 is how much? 79. 79 minus 73. So the value of IQR 6 here. Now we are interested to find the value of LR, means lower range. So now this lower range can be Q1 minus 1.5 into IQR. So here already we have the values of Q1, that is 73. Here, this is 73. So we have a 73 here, minus 1.5 into 6. So if we calculate, the expression gives us 64. So the lower range would be 64. Right, one is the lower range of this box plot is 64. Now say, that is according to the box plot, right? Now say we're having X value, and for the X value, we're having some lower values of X. And these values are 70, 63, and 60. By the analysis of the box plot, already we have calculated the LN value can be 64, not below 64. So if we have some lower values for x, 70, 63, and 60, then 60, 63 is those will not come because the minimum value is 67. Lower range is 64. Lower range is 64. So out of these values, the value which is acceptable, that is 70. So from the actual data set, we found that the value which is the minimal can be taken, that is 70. That's why 70 will be the minimum. So minimum equals to 70, which is the larger than 64. In that way, actually minimum is set up here. Similarly, if we find the maximum, how we can find the maximum can be found using the upper range. So initially we have to fix the upper range. So how we can find the upper range here? See, there's the upper range, that is LR. So that one can extend Q3 plus 1.5 times of IQR. So already we found IQR. And now if we put all those values here, already we have this value of x is Q1 equals to, already we have seen in the last slide, the 73, Q2 76, and Q3 79. And now if you put all the values here, then UR becomes Q3 plus 1.5 into IQR. So it becomes 79 plus 1.5 into 6. So now we calculate that it becomes 88. So upper range is 88. So the value cannot be greater than 88. So if some value ranges or if some value is lying outside 88, then we can say that is the outlier, right? So that is the upper range. Now see, we're having some upper values of x. And these values are x2, 82, 84, and 89. So out of these three values, we're looking at the maximum value which can be considered within the range, that is 84. Because 89 is out of 88, so that one cannot be considered. So now 84 out of all the upper values of x can be the maximum. So maximum is now set as 84 because which is the highest value lower than 84 out of all the upper values of x. So in that way, maximum can be set here. So whenever some values belonging to out of beyond of maximum and beyond of minimum, then it is these are the exceptional, or those can be treated as outliers. So whenever we do the box analysis, that we can understand any particular attributes are having some certain kind of outliers or not. So whenever we are finding that some kind of outliers are there, then either box plot can be used or some powerful outlier detection technique can be used here to find outliers, because from the box plot it is shown or it is seen that some kind of outliers are there. Fine. So now here how we can find Q1, Q2, Q3, all kind of things we are going to find with this example. So here we have a small example here. See, so these are the data values. So x1, x is the data values, and the values of the x can be 3, 4, 5, 6, 7, 8. But you try to understand these three in this data set, how many times? 4 times occur. That's why the frequency is 4, and that is called cumulative frequency for here. So 4 observations of x with value 3 is there, right? Means 4 observations are there. Similarly, with value 4, the value of x is 4. How many observations are there? 204 observations are there. So the cumulative frequency becomes 208 here. So here the value of 5. So how many time occurs? How many observations with value 5 is there? 3. Cumulative one is plus 3 here, 211. And with value 6, how many observations are there? 84. And now the cumulative frequency is 295. 7, no value is there, right? No observation with value 7 is there. That's why the count is 0. Frequency is 0. And the value with 8, how many observations? 103 observations are there, right? So the total becomes 398. So now if you talk about the total number of observations in this data set, then how many observations total we have here? Total number of observations we are having here, 398 observations we are having here, right? So from 398, we have to find the median, and the median is the Q2. Then how we can find the median? By 2. So if we divide by 2, then the number of observations, that is 199. So 199 observations is the median. But now we have to find the value of 199 observation. So 199 observations belongs to this range. because 4 times 3 occurs, then 200, 4 times 2 occurs, 4 occurs. So after 5, up to 200, up to 208, we are having the values 4 only. So the value of 199th observation is 4 only. Therefore, the median is 4 here. So we got the median here from this example, right? From the observations. Now, if you get the median, then half of the value will be upper and half of the value will be lower. So if you find the half of this, then it becomes 99.5. So 99.5 is upper, 99.5 is lower in terms of observation. So 99.5 observation we cannot find. So we can find by taking 99 observation and 100 observations if you find the lower values. So to find the Q1, we need to consider now the values of 99th observation and the 100th observation. So here to find the value of Q1, we have to find the average value of 99th observation. And here 100th observation. So if you find the average value, then it becomes 4. In the same way, so we have to give here Q3, so upper value 99.5. So if 99.5 is given to the upper values, then if we find the number of observations, then it becomes 298 observation and 299 observation. So the 9, if you find the average of those observations, see here that those observations belonging to this range actually, see here. So after 295, when 96 comes, the value is 8. 97 comes, 98 comes, then it will be 8. 299 comes, is 8. So all values are 8 here. Up to how many? 98 observations. So now if we find the average of 298 and 299, then the average value will become 8 only, right? So here we can find Q1, Q2, and Q3. And now we can find it very easily IQ1. How we can Q3 minus Q1? So the value of Q3 is 8. 8 minus 1, that is 4 here. Simply can find out. And LR value we can find very simply Q1 minus 1.5 into 4. So if you calculate this one, then the value becomes minus 2. So LR means lower range can be extended up to minus 2. But you try to understand in this data set, the lower value which is available, that is 3. That's why the minimum is only 3 here, right? Similarly, we can find the upper range. In Q3, we got the value of Q3. Here we have a Q3 plus 1.5 into 4 equals to 8. This expression gives 14. So the upper value can extend up to 14. But you see these values of the x, the upper value is 8 only. So this is within the range. That's why the max value can be 8 here. So in that way, actually, we can find all those 5 statistical summary of the box plot. So already we have discussed here with example. After box plot, we are having the histogram. By histogram, also we can visualize the data. What is the advantage of that? So we can have a quick understanding of the data. If we have a histogram, then we can quickly understand the behavior of the data. Here we have a number of values, a total. Now say we want to find how many values lying within say 30 to 40, then 40 to 50, then 50 to 60, then 60 to 70, like that. In different intervals, how many values are there? And we have a small data set here. So we are thinking that simply we can count, but you try to understand whenever deal with machine learning, we're having very huge database. 1,000 values can be there. So if you're having 1,000 and 1,000 values, can you count item wise how many values belonging to 30 to 40? You cannot do. So we can have certain kind of visualization tools so that we can understand how many values are belonging to that. So here from this data, we made one visualization. We made one graph, histogram, and then the graph of the histogram is like that. This is the image of the histogram. So from the histogram, we can understand very easily the values lying in between 30 to 40, that is only 1. And the values which is lying in between 40 to 50, that is only 4. Similarly, the 50 to 60, only 1. In that way, we can count, right? So whenever we have image of histogram, then we can understand the data distribution. Or we can understand how many values are there in which interval when the database size is very big. So another use of histogram is that, so we can have a database. Here I have taken 2 databases from machine learning repository, UCI repository, and the first one is the iris dataset, and second one is the thyroid dataset. So in iris dataset, we have 3 classes, and these classes are iris serosa, the iris versicolor iris virginica, right? Now we want to see how many classes are there which is belonging to iris sedosa and belonging to versicolor and belonging to virginica. So if we make a histogram of the class, then we can have this kind of histogram. So from this histogram, we can understand that the class level of the first class and number of second class, number of third class, all are equal. All are equally distributed. Now, if the same thing if you do for the thyroid data set, right? And here we're looking that there are two classes only. Thyroid is there or not? Yes or no? So looking that one of the class is more than 350, and another class is more than 50 only. So from here we can understand the database is not balanced. So whenever the database is not balanced, and if you give this database to a machine learning algorithm, then the algorithm cannot train or cannot train properly. Then the generalization capability of the machine learning algorithm on the data. So in such a situation, we need to have certain kind of treatment for imbalanced data. So whenever we have this histogram and we have an understanding that there is imbalances in data, then only we can apply the class imbalance problem. So whenever we apply the class imbalance problem here, and to give certain algorithms to treat, to make the data set balanced, then the accuracy becomes higher and higher, very much higher than the imbalanced data set. So to understand whether data set is balanced or imbalanced, so we need to see the class level, and if you see in the histogram, then this visualization will be very much easier to understand whether imbalances is there or not in the class level of the data set. So after that, again, we have another kind of data visualization tool, and that is called scatter plot. So up to here, the data visualization tool, whichever we have discussed, all those data visualization tools takes only one attribute and analyze it. But we try to understand whenever we have a two attributes, and we want to find some kind of analysis between two independent variables, then the concept of scatter plot will come. So here I have made one, I have made it, so this one is Python, once a scatter plot of the iris data set of two attributes between say sepal length and say petal length. So this distribution is like that. So if you find a relation, this relation is kind of a kind of linear relationship, right? So we can have a one independent variable, one say dependent variable. So between dependent and independent variable, whether linear relationship is there or non-linear relationship is there, if we make a scatter plot, then we can understand. So if there is linear relationship, then we can use certain kind of a linear regression techniques or linear classification algorithm to solve the problem. If the relationship is highly nonlinear, then we have to find certain kind of tool which can handle highly nonlinear problem. Or even again, if there is no relationship, if these are very much scattered, right? Very much scattered in this problem space, then we can say there is no relationship. If there is no relationship, then it's very difficult to solve this kind of problem. So those things we can understand if we have a visualization tool, then only we can understand what is the underlying behavior of the data. So today up to only data visualization and data exploration. So after data visualization and data exploration, whichever thing we have done theoretically, these visualizations, data visualization, data exploration, machine value handling, all those things we need to do in Python, right? So now we're going to exercise with Python all those things today. So before going to the Python, before that, we need to know certain kind of Python libraries, right? Even if it is not exhaustive discussion, but you will have a minimum discussion so that you can understand which kind of operations comes under which kind of libraries. So here we have taken some of the Python libraries which are specially designed for machine learning. The first one, see here, there's a NumPy. It's a numerical Python. It's an array processing package. It handles multi-dimensional arrays and matrices. And using this Python, different kind of modules are there. Those modules offer different kind of functions by which we can solve linear algebra, Fourier transformation, and random variables. Those things can be solved using the modules of the Python. And here we were trying to I have tried here to show you some of the popular functions which comes under NumPy. So these are the functions which comes under NumPy. So here I have taken 4 kinds of function. The first kind of function which comes under NumPy is array manipulation function. In array manipulation function, just I have shown here few function only. One is arrange. The format you will give right in Google Just you need to know these kind of functions are there so that you can understand. When you write a program, you can understand the function comes under which library. So arrange it here in the array. Then restep, another function that is available. From the name of the function, you can understand what is the function of the function, right? And the syntax are available in the Google, and in my slide is also available, but I don't need to discuss those kind of syntax, otherwise I cannot complete. So here, the same thing, array manipulations, again, we have the concatenate between, we can concatenate two arrays, array 1 and array 2. And then we have a numpy string functions. Then in the string function, we have a cat.add. Then we have capitalize. Then the next one here, we have a string function again, character.lower, then cat.upper, cat.replace. Those things are available under Python, right? So numpy arithmetic function, and these arithmetic operation functions are available. Add function, subtract function, multiply function, divide function, mod function, power function. These functions are available. And also there are some popular statistical functions are available. Median, we can find various using numpy. Mean, average, standard deviation, those things are available under numpy. So after numpy, this is the most popular, one of the popular Python library, which is especially for the data analysis, and that is called Panda. So in Panda, actually, there are two kind of data structures. Using those two data structures, it can handle a very huge amount of data. And those two data structures are called here, one is called series, and series is one-dimensional. And then the data frame, and that is two-dimensional. So using series and the data frame, we can handle huge amount of data. We can solve the problems of different applications like science, statistics, social, finance, and we can analyze different kind of the data. It can be say homogeneous data, it can be heterogeneous data, all kind of data can be handled using series and the data frame. So most of the practical, whichever we're going to see, using the data frame, right? So now under Python, Panda is a Python library. So under Python Panda library, there are number of popular functions, and those functions are going to be used. So some of the functions are highlighted here, but I'm not going to tell you what is the function right now. But during the exercise, during the execution, we will discuss the function of each of the function. So here we have a read CSV. So we have to read the file. So this function is used. Then head. Here we have a describe. So I'll discuss what is the, because during execution we have a describe. So then only we will discuss what is the function of the describe. Memory uses as type, LOC lock. Then we have to date time, value counts, drop duplicates. From the name of the function, you can understand what are the functions of those functions, right? Then group by. And here we have a mud, sort values, filna, step, columns, tail, data frame.info. And here D types, side, sample, is null, sum, and unique. Then we have index here, and smallest, and largest. And here we have a lock and ilock. The lock and ilock, two very popular functions by which we can handle the rows and columns, because in case of say pandas, the values are stored as a table. So in this table, we have to calculate the rows and columns. So those two functions are very much popular to handle the rows and columns, right? This is lock, LOC, and ilock. Then we have a slicing. By slicing, we can discard, or we can take a part of the data frame. That is called slicing. Then we have drop now. Query, we see a lot of queries, right? Then we have insert. Those functions are available under Python. So under the Panda. So after Panda, we have another kind of Python library that is called the MATLAB. Using matplotlib. Using matplotlib, we can visualize, and this is the data visualization library. We can plot. We can plot different kind of images. 2D plotting kind of things can be done using some matplotlib. So like say histogram can be generated, say error chart, scatter plot, so bar chart, all those charts can be made using the matplotlib Python libraries. So especially in our practical, we're going to use the three libraries, and these are three Python libraries, and these are matplotlib, pandas, and numpy. Apart from we are having here the popular So Python libraries, these are SciPy, or scientific Python. This library is specially designed for machine learning, right? And this library uses multi-dimensional array. And this library provides number of modules. By using those modules, we can solve linear algebra, image optimization, integration, interpolation, spatial function, fast Fourier transformation, and these kind of things we can do. Then we have scikit-learn. This is another kind of popular Python library function which is designed for machine learning. And using this scikit-learn, we can process, or we can do, or those things can be used for data mining and data analysis. And using this scikit-learn, we'll have a number of modules. Using those modules, we can handle, or we can solve classification problem, regression problem, clustering problem, dimensionality reduction problem, model selection, and different kind of pre-processing we can do. Then we have here Fino. Using this module, what we can do, we can work on GPU and CPU. Similarly, we have a TensorFlow here. The TensorFlow is specially designed for machine learning, right? And here we can compute which one, GPU, CPU, and TPU. And in the Keras is especially, this module is designed for neural network and machine learning. So using this module, we can work, or this module can be used to work on the images and text images that comes handy when we write a deep neural network code. So try to understand, if you want to implement deep learning, like say convolutional neural network or recurrent neural network, then we need to use Keras Python library. Here we have a number of modules. By using those modules, we can very easily compute the neural network and the convolutional neural network, means the deep learning kind of thing. Then we have here the PyTorch. Using PyTorch, what you can do, this PyTorch module can be used to compute computer vision, machine learning, and natural language processing. And one more here, number of Python libraries are there, right? I have shown here 11 only. So one more is NeuroLab. So this is very simple. Generally, I use NeuroLab to process the neural networks. So if you want to do certain kind of things using neural networks in Python, the NeuroLab can be used, right? So these are the libraries by which we can solve different kind of problems in Python. So here again, one thing, just I'm showing you here the what is the module actually. Module is nothing, it's a kind of file where number of definition of the functions are stored, like a header file in C programming. That's called module actually. And whenever we have a Python program, whenever we have this kind of thing, a.b, you see, whenever we write, this kind of thing will come. It means we are working with submodule B, and this submodule B comes under the package A, right? So if we write this one import sound, the effects of echo, it means that we are going to use submodule E, means we notes echo submodule, and which comes under package sound dot effect, and the same can be written in that way also. From sound dot effect import echo. So echo is a submodule, and this is the package. So now whichever functions we are going to use, which comes under echo, then we have to write echo dot this one. So here we note this submodule echo. So if you want to use one function that is echo filter, then we need to write like that. Echo dot echo filter, then the syntax here. So in that way, we're going to use, right? So this is about the modules which are available in the Python. This module we're going to use, not all, especially we're going to use 3 modules, then the pandas, NumPy, and matplotlib. So now we're going to see in let's say Python. So already in my laptop, already Python Jupyter notebook is already available. So I'm just getting it. So Jupyter notebook here, Jupyter notebook. So now it's ready. So whenever this one is ready, then this kind of window will come. And from here, so new and Python 3. Going to Python 3, the version is Python 3. Now my Jupyter notebook is ready here, right? So here I can write the comments, I can write the function here, and then I can execute. For example, I'm writing here, because our objective is machine learning. So I'll do from that perspective, but writing one function here. There's a print. There's a hello Python, hello. So it prints this one, right? Hello. So what is our objective here? Objective is to process the data set, right? So because we're talking about the machine learning. So initially the data set can, and those data set has to be imported to the Python interpreter. That's the objective, right? So we have to call the data set. So you try to understand here, we are going to handle with a CSV file. We're not going to use the Excel file. Why? Because Excel file takes lots of memory, but CSV file takes less memory. That's why, especially when you work in Python, in most of the cases, most of the users use CSV file. This is comma separated value file. So now looking how we can create CSV file, right? That one first. So see here, this part is over. So here I have D drive. See here in my computer, I have a D drive. So within here I have a data. So in data, I have one of the Excel file, that is sonar.excel, Excel assets. This is the file, and this is the Excel file, right? So this Excel file, so when we want to make it a CSV file, just when we do save as CSV only, nothing else, then automatically it is saved as CSV file. So path is same, just I change the extension, and that is a CSV. You can CSV, that is only CSV file. I made a CSV file. So I have now, that is a CSV file, see here, right? And then this is the Excel file. So now looking, so if I keep the Excel file here, see the content of the Excel file. So the contents, so these are the content of the Excel file here in the notepad. These are content, right? These are content, huge content is here, right? And now, if I see the CSV file, see here, we can see the content. So this is the CSV file we can see here. So generally the CSV file takes less memory. That's why CSV file is used specially. So now I'm not going to use this file, the file which are stored here, because already I have done earlier the programs, all the programs that I'm going to show you one by one, and then to explain, all my files are stored here. All my files are stored here. So this is the path of the file. This is the path, right? My files are available here. So now I want to invoke the first file. I want to read. So today, how we can read? So we can read using Panda. So first of all, we have to invoke the Panda here. That is import Panda as PD. This is alias. Aliasing is available, means permitted. So directly we can write import Panda. Then each time we have to write Panda and then the function. But you try to understand now this Panda can be referred as PD. The aliasing is permitted. So now run. So now Panda is available as PD. This one is PD is written, but try to understand, we can change the name also. There is no problem. So here, invoking the file, here we have this file. Oh, sorry. Simply here we have, the file is already imported now. And this file is imported using this one, the read CSV. So as we are going to import the CSV file, that's why it is written as PD dot read CSV. This is the function, and within the function we need to write the file name here. But I try to understand file is stored in this path. That's why I have given the path here. This is the path. So how we can get the path? Simply we can get the path from here. See here, that is the here. My files are available here, right? So which file which file is being imported? Data 4, right? So see here, data 4 is available here. So data 4 is available here, right? So the path is this. So whenever I click here, I will get the path. This is the path. This is the whole path, right? This whole path is written here. Path is written here. Path is written here, and then a file name. File name is data4.csv. Just I have written this thing, and now automatically the file is imported. And that file is that file is available to the variable that is f2. So f2, if you print f2, then you can get here. That's the file. This file is available. This is my file, CSV file. You can see here the content of the CSV file. I'm showing you here the C this code. This is this is the content only. This is the content only. So this content is available. Don't save. Okay, the things whichever we're going to do, we are going to do using this file, data2 file, because before starting the machine learning algorithms, we need to know number of basics of the data frame. So we're going to do the number of things which are to be done before doing some machine learning. We're going to do those things. So here we have this one F2. Writing here F2. Here I have the D2. Initially I had it data 4, but I am trying to operate with data 2. So data2.csv file is available here. So this one F2 is available. If I click F2, we'll get the file here. So I have this file. Well, I have taken this file because in this file I have the missing values here. I have missing values here, missing value here, missing value here. So we are going to treat the missing value. That's why I have taken this file here. So after doing all those things, when we execute, then we'll execute and we standard database, iris database, thyroid database, diabetes database. We'll do all those things, right? But it's starting with a small data set so that you can understand very easily all those things. So now here, by this, we can see the shape of the file. See here, the shape of the file, one by one, showing you the shape of the file. Shape of the file means what? You can say how many rows are there. So 20 rows are there. How many columns are there? 6. This column is not included. You try to understand. This is called index actually. This index is automatically created. This index is not calculated, right? So how many columns? 6 columns. 1, 2, 3, 4, 5, and 6. And then which one? Then we have here. If you want to see that these columns and rows differently, then we can use like that. Already you know basic of Python. Already because I have this news, I have this information actually. So if you see, then you can see here. This is R means this is row. The double values, it produces two values, right? The first value is assigned to R and the second value is assigned to C. And then printing separately, that's why print R, print C. So 26. So separately we can print like that. And after that, if you want to see the head of the, let's see, already we have seen the head function, one of the function that is head. See here, head function here. So head is here. We're doing head with head. Here head. So here shows here. See the output here. So here is showing you the first rows of the file. 1, 2, 3, 4, 5. And to try to understand the first row started with 0 index, right? So 0, 1, 2, 3, 4. 0 is how many? 5. So whenever we execute f2.head, this function, it means how many rows we are going to see the first 5 rows. Similarly, we have here tail, the last 5 rows we can see. Last 5 rows we can see here. Run. So last 5 rows you can see here. So now we can see any number of rows. Here if we put the values, right? So head's a 10. So we want to see how many values from the beginning 10 values, 10 rows. So run here. So how many 10? So 0 to 9, 10 values. This part is here. Similarly, we can see the rows from the bottom by using the tail, the end here, like that. So one thing, right? Whenever we have a big database, see here that I'm showing you one of the database. Let's say this one. Wait, big database. Yeah, here I have it. So this is a big database, iris database. Just I'm showing you here. So already path is given here, right? The path can be given in this way also. R can be written in 2 ways. Here I have seen one way that is different than this, right? So you can do any one of the way. Just if you just I'll give you this kind of syntax I'll give you. So if you run this one, so already this file iris.csv is now imported to one variable that is f1. So now we can see f1. See here. So how many values we can see? Because f1 is given how many? Total number of rows, how many? 150, right? But at a time we cannot see 150 because by default the value is 10. Maximum 10 rows we can see, the 5 first row and 5 last row. Now if you want to see the whole data set, then we have here one say function. By that one, if you execute that one, then the default value is removed. The function is, where is the function? Where is the function? Here is the function, right? Here is the function. See here, the default value maximum is none. Default value is 10. You try to understand, right? So here I have done it none. Means now no first 10 value means first 5 and last 5. Now whole data set can be seen. If you execute this one, then the whole data set. Now just we're trying to see F1, the whole data set. The whole data set can be seen now. Because this data set is only 150 rows. You can see like that, right? Once it is said that, whenever I want to see one file, the whole file can be seen now. This part is over. Then printf. Now the range of rows, right? Okay, the range of rows, how we can do it. So see here the all the range of rows. You see in this way actually range of rows can be invoked. Already we have a F2. Already we know one file is imported to F2. But if you want to see the 2 to 6 means 2 to 5 actually, then we can run. If we can run, then we can see here. See column number, row number 2, row number 3, row number 4, and row number 5. Before here, this is the 6 is the uppermost range, and then -1 up to -1 index we can see. So this is up to 6 means 6 values. I try to understand the index 5 represent the 6 values because index is started from 0. So here we can see number of rows. Now, if you want to see alternate rows of the whole data set, telling you the meaning of those things, this thing. What is that here? The starting point is a 0th index, and this one is what? This one is called say last index. So we didn't give here last index. So by default it is end of the file, and here we have a step size. So step size is 2. It means one alternate, one after another. So we can see now the alternate columns of the whole, alternate rows of the whole file. Fine, and then which one we have? Then we have two most popular functions, and these are the log and ilog. What is the meaning of that? See here, if you execute log, then execute log, and what will be the output? See here. So it shows which one? It shows rows 2. It shows the rows 2 in detail. Rows 2 in detail. See that this is the rows 2 in detail, right? It is the meaning is written here, the column wise data for row 2. So now in detail we can see if whenever we execute this one. Now if we want to see all rows up to 3 index, then what we need to write? We need to write the, in this way we write the index. Indexing can be done within this function in that way. This is what actually, this is slicing. This is indexing actually, so the index, and yeah, sorry, this is now slicing. Means if part of the data set we are going to see that part is called slicing. Indexing means we are going to exactly point out one of the rows. So here you can see here the tree, that's a part of the data set, right? So here it means what, all rows up to which one? From 0 to 3, right? From 0 to 3 we are going to see here. And thereafter we have here, if we find the ilog, see the differences between log and ilog. So in log, if it is 3, then up to 3 we can see, but in log up to 2 we can see only. So here, so that is which one? It is talking about location of all the rows. This is all the rows, start to end. And comma means after that we are having columns. How many columns? Column 1, 2, 3. So column 1 and 2, because 3 is there, before 3 you have to check. So 1 is this and 2 is this. So that's why we're looking column 1 and 2 and all the rows. It means all the rows. You try to understand when you split the data set, this function is required. That's why I'm showing you this function. Because we have to split the data set, right? So we have to split in say column row wise, but here I'm showing you the column wise, right? But I'm also I'm going to show you row wise also. So this is And another function is this one. Here we are going to see the first 10 rows only and all columns. This one you can see here up to here. So see here. So we have which one? We have now rows from 1 to 10, 1 to 10, comma, and we have all the columns now, right? All the columns, 0 to all of the columns. So not this one. We get, see here. We have all the columns now, 1, 2, 3, 4, 5, 6. And how many? 0 to 10 means how many? 1, 2. So 1 to 10 means 1 to 9, what we talked about earlier. So in that way, actually, we can split the data set using this iLog function. So this function is especially to split the data set. So madam, today is enough, I think, right? Already it is more than 1.5 hours, I think. So my students are exhausted, I think.
Yeah,
Next,
it is your wish. You can stop now. No
so
problem.
next day, before starting the lecture, we'll see the practical, how we can handle the missing values, and how we can create the box plots and different kind of histograms and scatter plots. Initially, do the practicals, then we will start the lecture.
Sir,
Next.
all the participants are asking for the data sets and all these files. Your PPT also. Now the students are asking some doubts.
I'll give everybody. I'll give all the things, right? But before you just try to see all the things. Just we have started here. Then you see gradually we can train the model. We can find the accuracies. We can do outlier detection, or the data imbalance, all kind of things we can do one by one. And things are so simple, right? Using functions.
Sir, they have some queries, sir.
Yeah. Then put the queries so that I can answer.
Students, you can, or participants, you can write in the chat box. Otherwise, you can unmute and speak to the speaker. Speak with the speaker.
You can talk, right? Don't write in the chat.
5P9 is asking, sir, can you use cburn in this course?
C1.
cburn Python library. Are you
Yeah,
going to use in this
no,
course?
yeah. I'm going to use, but already I told you that these are the some of the machine learning libraries. Seaborn is going to be used, right? Whenever we are going to use, initially the libraries are called, only then we'll execute the functions. So we are coming gradually, right? Just we have started with this introduction with 11 library Python libraries. I have shown the 11 Python libraries, but there are number of Python libraries, right? C1 we're going to use, right? Okay.
One more doubt from a student, that how machine learning is used in data science.
So this is the data science. We try to understand handling the data. Data science means what? We're handling the data, segregating the data, finding some of the interesting facts, finding the relationship from the data. That is called data science. So we are going to use all the machine learning algorithms, especially this course is ML for data science, because here I have taken all the numerical data. I did not take other than numerical data. So especially the things which comes under data science, we're going to do all of the things using machine learning. Data science can be done using statistics also. It can be done using some basic mathematics also. But you try to understand, if you don't have a machine learning algorithm, then it will take more time, because whenever you write conventional programs to handle you say statistical data, to handle say data using say statistics and say basic mathematics, then you will take longer time. And already I told you, machine learning is used to make reliable and quicker decision, right? And where the algorithms are not available. If the algorithms are not available, we can use a basic mathematics and statistics kind of thing. But I try to understand, and it takes a lot of time. But to save the time, to make a quicker decision, because nowadays the business organization, there is a big competition, right? So they are trying to generate the data, generate the inferences to take the decision very quickly. That's why people are using different kinds of machine learning tools and techniques in data science.
The next question, sir. What is the difference between KNN and K-means algorithm?
Oh no, we have a K-means, KNN. Still, we didn't go there. You try to keep your passions. Everything I'll show you mathematically and theoretically. So K-means is a clustering algorithm. KNN is also supervised, unsupervised. But using KNN algorithm, especially we solve the classification problem that especially belongs to supervised learning. But KNN also can be used as unsupervised learning, but especially it is a classification algorithm, right? And K-means is a clustering algorithm. So k-means part is not going to cover here, because if I include k-means, all those things, I don't have any problem, but it will take more than 50 hours, more than, because just we have started, still you didn't see any mathematical part. So when coming the mathematical part to explain each algorithm, it will take more than 1 hour. So I have all the algorithms, no problem, right? But here we're going to talk about KNN, talk about decision tree, random forest, and the net-based algo classifiers. And these classifiers we're going to talk about, and all, and then still, because if you are the learner of machine learning, you don't know many of the things, because there are a number of algorithms in imbalance data handling. So we are going to see all those algorithms, not all, a part of those algorithms. Similarly, for outlier detections, we are having a number of algorithms. For feature selection, feature extraction, we have number of algorithms we are going to see mathematically, and then we'll implement in Python. So still I'm thinking that we will say 10.5 hours is not possible, because by 7 days I get 10.5 hours, because beyond 1.5 hours, my voice is not going actually. Now my voice is going down.
The next question. Which type of machine learning model is used in object detection?
Object detection. Correct. Object detection is the image processing tool, image processing problem, right? Image processing problem. So we need to use, already I have shown you, say for image processing, we have a number of modules. But in here, we are not going to use that module. Already I have shown here in the module, right? For the images, we have the modules here. For image processing, see here, this module, which module I have shown, I have shown you this module. PyTorch can be used because of computer vision, especially PyTorch is used for the natural language processing. So you have to see the function of this module, right? PyTorch. And for apart from PyTorch, again we have here the SciPy we have here. Using SciPy, we can see image processing. So the modules and the functions which are available, simply you try to understand. Now, if you are the beginner, you try to see how data can be processed using pandas and numpy. Then you can have an idea whenever you have a module, you have a function, then the image processing can be done very easily in Python. Very easily. Just you need to write, you need to know only that, you need to know the calculation. This is row, this is column, this is that. And then using the functions, you can handle it very easily, right? So object detection is a kind of image processing problem.
Participants, any other questions?
So to keep the questions, whichever questions they will have. So next, before starting the session, I'll answer. 1 to 2 questions I can answer.
Okay, sir.
More 1 to 2 questions I can answer. You can read it out.
The student is asking the object detection comes under classification type learning or not?
Yeah. You try to understand object detection. Yeah, it's a classification problem, right? But image classification. If you want object detection, right? If you detect the object, which class, or not, this is a classification problem, right? But I have shown you the flow chart, the flows, how to process the machine learning model. Especially this is for the data science. Similarly, when I do image classification, again we need to have a number of phases. Like we can have, say, a feature extraction and a feature selection, right? Then we have the classification of the features like that.
One more last doubt, sir. How ML plays a vital role in industry?
Already I have shown you, right? Already I have shown you one application here, one application in my slide. Already I have shown you here one of the applications. So here we talked about one of the application here, right? See, because they are putting the question arbitrarily, I think they are not listening properly. If you listen properly here, already talked about, this is the stock management on whenever you are going to put some orders for some items, so that in future there won't be any mismatch between the items. So here, by doing machine learning, means by doing some mathematical calculation, right? We can find the dependency, or we can find some conditional probability between 2 items. So here already you have seen that if you have 2 items, a beer and chip, from the historical information, if we can find that the conditional probability is 0.7, it means that this is the probability of the chips given beer. It means if somebody is taking or buying a beer, the person is having a probability to buy chips is 0.7. So whenever you are going to put orders for the items, especially for the supermarkets, they are giving the other thousands packets and thousand bottles. So if they put 100 bottles of, if they push an order of 100 bottles of beers, at the same time they have to give an order of 70 bottles, 70 packets of chips. So this one, how we can find? This one can be measured by doing some machine learning processing, and that task is called association rule mining. And here we're finding the dependency between two items, right? In that way, actually, it can be used. So if you have a practical data, if you have the practical real life data from any supermarket, you attend the classes, attend all the lectures, then you can analyze the data set and you can tell them some of the interesting thing about the data.
Okay, sir. So these are the queries for today's class. Thank you so much, sir. Can you switch on your video once, sir?
Oh, thank you, participant. Thank you.
Thank you so much, sir, for taking this valuable class, and you have talked very minutely, as if we are listening in our regular class works. Thank you so much for taking this class, and we'll meet you tomorrow. And all the participants are asking the slides, your syntaxes, the data sets, and all. I have told them that we will share. So one more last doubt, that what algorithm will be used for text analysis?
We are not doing here the text analysis, right?
Just name the algorithm.
Which kind of text analysis? You try to understand. I'm
Okay.
telling one thing. When you find, because text is a vector, whenever we represent in machine learning, if you have a two text kind of thing, if you want to find the similarity between the two texts, similarity, you try to understand similarity between two texts. A text is represented as a vector. So we can have a number of keywords for a particular text, and again we can have number of keywords for a particular text. Now, if we want to find the similarity between two texts, then we can use any co-similarity measure or the similarity measure. One of the famous similarity measure for the text analysis is called the cosine similarity. So using cosine similarity, we can find what is the similarity between two texts, right? So that is also would be covered. Cosine similarity we have, and how to calculate, all the calculations are available. In the text analysis, which kind of analysis you are going to do? Either you are going to do, say this one, classification some text, or you are going to speech recognitions, or you are going to machine translation, because in text analysis, say Hindi to Bengali, say Bengali to English kind of thing, those things are done actually, right? And if you talk about the classifiers, so the same classifiers can be used, but you try to understand whenever we process a text. So if you have a time, then I can give you one special class for text processing, because whenever we have a text, initially the text can be represented. So there are two kinds of model. One is called vector space model, and another one is called vector space model, and another one is called I'm just forgetting vector space model, and then this one say matrix kind of thing, right? So I can show you that one, right? Vector space model and I cannot recall properly. So in that way, actually, these are represented. Then it becomes a keyword, right? Then we have to find the similarity, probability. Calculating the probability, we have to use the classifier. So the classifier, what we are going to see, like say for an example, name-based classifier, right? So this name-based classifier can be used. The name-based classifier can be used for the classification, a text classification. Wait a bit, one minute, madam. I'm looking on whether I have taken this slide here or not. Generally, in the here you can see here. So there is two kind of here. My slide is visible.
Yes, sir.
So you see, whenever we have a textual data is represented in two ways. One is called vector space model. Another one is called graph-based model, right? So we can have a text, but you try to understand when you represent it for the computation, the texts are represented like that. If this text is this string, what is available in the text, then for this one, we can keep one or the number of frequencies, how many times it occurs. In that way, the texts are represented internally. And then we apply the common machine learning tools and techniques here to process the text actually. But I'm coming to that, right? You can understand very easily.
Okay,
Keep
sir.
your patience.
Thank you so much, sir. So shall we conclude today's session with your permission?
Thank you
so
madam.
much. Thank you so much for taking this valuable class, sir. We'll meet again tomorrow, all
Thank you, madam.
participants. Thank you so much.